In this video, we will learn how to find the sum of an infinite series using the binomial theorem. Let us look at the first question. 1 plus 2 into 1 by 6 plus 2 into 5 by 2 factorial into 1 by 6 square plus 2 into 5 into 8 by 3 factorial into 1 by 6 cube plus etc. Let the sum of the given series be S. Then S is equal to 1 plus 2 by 1 into 1 by 6 plus 2 into 5 by 1 into 2 into 1 by 6 whole square plus 2 into 5 into 8 by 1 into 2 into 3 into 1 by 6 whole cube plus etc. Now compare this with the standard binomial expansion. Consider the third term of the given series 2 into 5 by 1 into 2 into 1 by 6 whole square. The corresponding third term of the standard expansion is p into p plus q by 1 into 2 into h by q whole square. By comparing the two expressions, we get p is equal to 2, p plus q is equal to 5, h by q is equal to 1 by 6. Hence q is equal to 3, h is equal to 1 by 2. Now apply the standard result. S is equal to 1 minus h whole raised to minus p by q. Substituting the values, s is equal to 1 minus 1 by 2 whole raised to minus 2 by 3. This simplifies to 1 by 2 whole raised to minus 2 by 3 equals 2 raised to 2 by 3 equals cube root of 4. Therefore, the sum of the given infinite series is cube root of 4. That is our answer. Now, let us solve another question using the same method. Consider the series 1 plus 3 by 4 plus 3 into 5 by 4 into 8 plus 3 into 5 into 7 by 4 into 8 into 12 plus etc. Let the sum of the series be S. Then S is equal to 1 plus 3 by 1 into 1 by 4 plus 3 into 5 by 1 into 2 into 1 by 4 whole square plus 3 into 5 into 7 by 1 into 2 into 3 into 1 by 4 whole cube plus etc. Now compare this with the standard binomial expansion. The third term of the given series is 3 into 5 by 1 into 2 into 1 by 4 whole square. The third term of the standard expansion is p into p plus q by 1 into 2 h by q whole square. Comparing the corresponding terms, we get p is equal to 3, p plus q is equal to 5, h by q is equal to 1 by 4. Hence q is equal to 2, h is equal to 1 by 2. Now s is equal to 1 minus h whole raised to minus p by q. Substituting the values, s is equal to 1 minus 1 by 2 whole raised to minus 3 by 2 equals 1 by 2 whole raised to minus 3 by 2 equals 2 raised to 3 by 2 equals 2 root 2. Therefore, s is equal to 2 root 2. Now, let us consider one more example. Find the sum of the infinite series 1 by 4 plus 1 into 3 by 4 into 6 plus 1 into 3 into 5 by 4 into 6 into 8 plus etc. Let the sum of the series be S. Then S is equal to 1 by 4 plus 1 into 3 by 4 into 6 plus 1 into 3 into 5 by 4 into 6 into 8 plus etc. is equal to 1 by 2 into 1 by 2 plus 1 into 3 by 2 into 3 into 1 by 2 whole square plus 1 into 3 into 5 by 2 into 3 into 4 into 1 by 2 whole cube plus etc. Before comparing with the standard binomial expansion, we have to rewrite the series. Notice that the denominators do not begin with 1. So, we introduce the missing factor 1 in each denominator. Also notice that the number of factors in the numerator is 1 less than the number of factors in the denominator. To make the numbers of factors equal, we first observe that the numerators form an arithmetic progression with a common difference 2. So the term preceding in this progression is minus 1. Therefore, we multiply both sides by minus 1. This gives minus 1 into s equals minus 1 into 1 by 1 into 2 into 1 by 2 plus minus 1 into 1 into 3 by 1 into 2 into 3 into 1 by 2 whole square plus etc. In the standard binomial expansion, the power of the variable must equal the number of factors in the numerator and denominator of the coefficients. So, we multiply both sides by 1 by 2. Then, 1 by 2 into minus 1 into s equals minus 1 into 1 by 1 into 2 into 1 by 2 whole square plus minus 1 into 1 into 3 by 1 into 2 into 3 into 1 by 2 whole cube plus etc. Even now, the first two terms of the standard binomial expansion are missing. The missing terms are 1 minus 1 by 1 into 1 by 2. So, we add these two terms to both sides. Then, 1 minus 1 by 1 into 1 by 2 plus 1 by 2 into minus 1 into s equals 1 plus minus 1 by 1 into 1 by 2 plus minus 1 into 1 by 1 into 2 into 1 by 2 whole square plus etc. Now compare the third term or the RHS with the third term of the standard binomial expansion. We get p is equal to minus 1, p plus q is equal to 1, h by q is equal to 1 by 2. Hence q is equal to 2, h is equal to 1. Therefore, 1 minus 1 by 1 into 1 by 2 plus 1 by 2 into minus 1 into s equals 1 minus 1 whole raised to 1 by 2. That is 1 minus 1 by 2 minus 1 by 2 is equal to 0. That is 1 by 2 is equal to 1 by 2. Hence s equal to 1. Therefore, the sum of the given infinite series is 1.